Today we're embarking on an incredible journey not to the stars but deep, deep beneath our very own feet. Forget everything you thought you knew from your middle school science textbook. You know the one. Crust, mantle, outer core, inner core. It's a neat little diagram, but it barely scratches the surface of the truth. What if I told you there's a lost world hidden inside our planet? A mystery thousands of kilometers down that is completely rewriting the story of Earth? So picture this. We travel down, past the ground we walk on, through the rocky mantle for nearly 3,000 kilometers. We've now reached a place of unimaginable pressure and heat. This is the core-mantle boundary, the dividing line between the solid rocky mantle and the swirling liquid iron outer core. For decades, scientists pictured this boundary as a relatively simple, smooth line. But recent discoveries have shattered that image, revealing a landscape more bizarre and alien than anything on the surface. Imagine massive mountains, some 5 times taller than Mount Everest, and vast continent-sized blobs of strange, dense material just sitting there. What on earth is going on down there? This is where our story gets truly fascinating. These strange structures, officially known as large low-shear-velocity provinces, or LLSVPs for short, are a colossal puzzle. One is lurking under the Pacific Ocean, and the other is beneath Africa. When seismic waves from earthquakes travel through the Earth, they slow down dramatically when they hit these zones. This tells us that whatever these blobs are made of, it's not normal mantle rock. It's denser, it's hotter, and it's different. This has thrown geophysicists into a frenzy of questions. Are they ancient remnants from Earth's formation? Are they graveyards of tectonic plates? Or could they be something far more extraterrestrial? Let's rewind the clock about 4.5 billion years. Our solar system was a cosmic construction zone. A young, molten Earth was just getting its start when, bam, a Mars-sized protoplanet, which we call Theia, slammed into it. This colossal impact was so powerful it blasted a huge chunk of Earth's material into orbit, which eventually coalesced to form our moon. This is the widely accepted giant impact hypothesis. For a long time, the story ended there. Theia hit us, we got the moon, and the rest of Theia's material either flew off into space or was completely mixed into Earth's mantle, like stirring milk into coffee, leaving no trace. But what if that last part isn't true? A groundbreaking new theory proposes that large pieces of Theia weren't completely mixed in. Imagine trying to mix oil and water. They separate. What if chunks of Theia's iron-rich mantle, denser than Earth's own mantle, survived the impact? Instead of blending, these massive fragments would have sunk through Earth's magma ocean over millions of years, eventually coming to rest on top of the core. Could these mysterious blobs at the core-mantle boundary be the long-lost remains of the very planet that helped create our moon? This idea is a game-changer because it means pieces of another world are still inside our own, like a planetary time capsule. So how do we test this wild idea? Scientists are using supercomputers to create incredibly detailed simulations of the giant impact. They model different scenarios. What if Theia was richer in iron? What if the impact was more of a glancing blow than a direct hit? By comparing the results of these simulations to what we observe with seismic waves, they can see which models best explain the existence of these giant, dense blobs. The latest simulations are showing that it's entirely plausible for significant portions of Theia's mantle to have survived and settled at the core-mantle boundary. It's like cosmic forensics, piecing together the clues of an ancient planetary collision. This isn't just some abstract geological curiosity. The presence of these blobs could explain a lot about our planet. They are believed to be much hotter than the surrounding mantle. This heat isn't just sitting there, it wants to rise. This could create what are known as mantle plumes, massive upwellings of hot rock that travel all the way to the surface. When these plumes break through the crust, they can form volcanic hotspots, like the ones that created the Hawaiian Islands and Iceland. So, the ghost of a long-dead planet might be directly responsible for some of the most dramatic volcanic features on Earth's surface today. It connects a cataclysmic event from billions of years ago to the dynamic, living geology we see all around us. But the implications don't stop there. These blobs could also influence Earth's magnetic field. The magnetic field, which protects us from harmful solar radiation, is generated by the churning liquid iron in the outer core. The core-mantle boundary is where this process begins. If you have two continent-sized piles of chemically different, super hot material sitting on top of the core, they're going to affect how heat flows out of it. This, in turn, could influence the patterns of convection in the liquid core, essentially stirring the pot in a unique way. Understanding these blobs could be key to understanding why Earth's magnetic field behaves the way it does, why it flips polarity every few 100,000 years, and why it's so crucial for life on our planet. Of course, this is still a developing area of science, and not everyone is convinced. Other theories for the blobs are still on the table. One popular idea is that they are graveyards of subducted oceanic crust. For billions of years, tectonic plates have been diving back into the mantle. Some scientists argue that this old, cold, and altered crust could pile up at the bottom of the mantle over eons, forming these dense regions. It's a battle of ideas. Is it material from above or material from beyond? Distinguishing between these two possibilities is one of the biggest challenges in geophysics today. We need more data, more precise seismic imaging, and better models to solve this subterranean enigma. The quest to understand the core-mantle boundary is pushing the boundaries of technology. We can't just drill a hole and take a sample. The pressure and temperature are far too extreme. So scientists are getting creative. They use networks of thousands of seismometers around the globe to create a sort of CAT scan of the planet's interior. They also recreate the insane conditions of the deep Earth in labs, using diamond anvil cells to squeeze tiny rock samples with pressures millions of times greater than at the surface. By studying how materials behave under these conditions, they can better interpret the seismic signals coming from the deep. It's a slow, painstaking process of piecing together clues from a world we can never visit. So, the next time you look at a simple diagram of Earth's layers, remember the incredible, hidden complexity. Deep beneath us lies a mysterious landscape of towering mountains and strange continents that could be the remnants of an ancient planetary collision. These remnants might be influencing everything from the volcanoes that shape our islands to the magnetic shield that protects our very existence. The story of our planet is far from complete. In fact, we're just beginning to read its most fascinating and deeply buried chapters. The enigma below us is a powerful reminder that some of the greatest discoveries aren't in the distant stars, but right here, inside our own home. Thanks so much for joining me on this journey to the center of the Earth. What do you think these blobs are? Let me know your theories down in the comments. If you enjoyed this deep dive into our planet's mysteries, don't forget to hit that like button, subscribe for more adventures into the unknown, and ring that notification bell so you never miss an episode. See you next time.